Now let's take a look at Hawaii in the Midway Atoll. So we'll look at these in terms of examples of high islands and low islands. So we'll zoom into Hawaii. Of course, Hawaii, we can see the diverse colors, greens and blues and dark browns and dark browns and grays. That really speaks to the variety of environments we'll find here. So although this isn't 3D, we can just still imagine that this particular part of land is just poking up above sea level, but below it, actually, this all combined is the largest structure on Earth. And so this is, albeit mostly underwater, it is actually the biggest from where it starts to its top, the biggest thing you'll find on Earth's surface. So let's go ahead and look at its topographic profile. And to do that, once again, we'll go to our good friend, the Geocontext Center for Geographic Analysis profiler. So I'm just going to go from the north side of the island to the south side of the big island, and we can see the topographic profile. So of course on one side of the island, then we have the island, and then we have the other side of the island. So this is an interesting situation here in which you have actually these two peaks, which is actually quite common from these volcanic essentially structures, that you'll kind of get the inside will kind of cave in and leave behind a lot of the outer rim structure to create this kind of this two peaks, twin peaks, so to speak. But right there is actually the top of this sucker. And so combined, all of this here is the world's biggest feature in terms of height that you'll find on Earth. And so that's its topographic profile. So now let's go take a look at the Midway Atoll. The Midway Atoll, a different feature, is a good example of a low island. Now the Midway Atoll was actually formed over the same feature that is still forming the big Mauna Kea island that I just showed you, the big island, but at the same time this sucker is much smaller. So here we see the Midway Atoll. And so it's the rim of a submerged volcano. You can see its volcano shape. It's the rim of it's just enough to poke above the sea level, in which there's bits of coral and bits of other things that have over time collected to form just enough of a surface in which if you zoom in to the Midway Atoll, you can actually see that there's an airport there and other things. And so just so you can see that submerged rim of a volcano that we just showed the profile here in this low island. In this video I'm going to further, I hope, explain and showcase various concepts I've previously discussed. So the key idea here when we look at the ocean, the darker the blue, the deeper the ocean, the lighter the blue, the less deep, the more shallow it is. And so going back to Southeast Asia, it's quite shallow along this particular area of Southeast Asia, where along this line we see the deepest part of the ocean. So the deepest part of the ocean is not in the middle of the ocean. So let's go ahead and look at the deepest part. So we go to the Pacific Islands, and I mentioned the deepest part is the Mariana Trench, and more specifically right here is what they call Challenger Deep, which is the deepest part that you can go anywhere in an ocean, anywhere on Earth. So what's this simply happening there is a trench. One plate is going underneath another plate. We can kind of see these plates just in this map that shows topography of the essentially the underground surface underneath the water. That didn't make any sense, but whatever. So what we have here is the Philippine plate, which we can see is going underneath the Eurasian plate. And where that plate collision is occurring, the Philippine plate, which is heavier, is being forced underneath and thus creating a trench right along here. And so the Filipino Islands are essentially examples of island arcs, much bigger island arcs than the ones we see here along the Pacific plate boundary colliding with the Philippine plate. So the Philippine plate that's right here is essentially getting having collision on two sides. It's heading that direction, so it's colliding with the Eurasian plate, but at the same time, moving faster is the Pacific plate, which is colliding it from so-called from behind. So we zoom in and we see along this trench is where we find island arcs. And so once again, these trenches where the plate collision is, you're going to find the trench on this side of the island arcs. And so that means this plate is colliding with this plate and thus going underneath it, creating the island arc. So just a small little sliver of these island arcs are above sea level, thus creating landforms. And we know those is, in this case, is Guam and Northern Mariana Islands, two U.S. territories. So let's go to the topographic profile and take a look at this. We go ahead and now let's look at Guam. So we're going to go right through Guam. We're going to go from one side to the other. And we can see the topographic profile right through here. This is the Philippine plate all through here. But what's happening is the Pacific plate is going underneath it, being forced underneath it, and there is our deep ocean trench, the Mariana Trench. That small little part that's above sea level, above the green, is the small little livable part of this particular area called Guam, and of course the Northern Marianas also pokes above the surface.